this particular lab involves taking measurements. And when you take measurements, you have to know the calibration of the measuring device. Because if you don't know the calibration of the measuring device, you're going to take an incorrect measurement. When you use a ruler and you measure, for example, the height of this particular marker, you don't want to say 9.6785 centimeters, because your ruler is not going to measure it to that precision. At the same time, you're not going to say 9 centimeters, because your ruler provides better precision than that. Okay, so we're measuring everything with the metric system. So if you take a look at that ruler, it happens to be a meter stick, which means that it's a meter long. And if you take a look at the side that reads centimeter, you will see that there are, it goes from 0 to 10 to 20 to 30 to 40, all the way to 90, and then they don't show 100. But each of those segments is a decimeter. It's 1/10 of a meter. Okay? And if you take a look at what the decimeter, and you look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, each of those is a centimeter. So there's 1 centimeter, 2 centimeter, and then below that there's even finer calibration. So right now we have a meter stick, and that's 1 meter long. And this thing is split up into 10 segments. And each segment is a decimeter. A decimeter is basically 1/10 of a meter. And each of those decimeters is broken up into 10 segments. And each segment here is a centimeter. And then each centimeter is broken up into 10 segments. And that's the important part right there. I can't draw that fine a calibration, but you should see 10 lines between each number. And that's a millimeter. Each of those is a millimeter. Okay? The smallest calibration mark on your ruler is 1 millimeter long. So delta in your ruler is 1 millimeter. Or how many centimeters? Not 10 centimeters, but each one of these is, from here to here it's 10 centimeters. So for one of these guys, if we blow it up, okay, it would be 0.1 exactly. Each one of this would be 0.1 centimeter or 1/10 of a centimeter. Thank you. 0.1 centimeter. Now this is important. Before you start any measurement, you want to look at the finest calibration of that measuring device. And in this particular case, it's 0.1 centimeter, because the precision of this particular ruler now is going to be to the 100th of a centimeter. It's always 1 decimal point over from the smallest calibration. So the fact that your smallest calibration is 0.1 means that you're reading this ruler to 100th, or 0.01 centimeter. Okay? So all your measurements today, when you're reading a measurement, better be to 100th of a centimeter. Don't just say 5.6 centimeters. You have to say 5.60 or 5.65 or 5.62. Don't just say 5.6, because that's the precision of this particular ruler. And you guys are going to be using these rulers in your measurements. Okay? So that's the first part. The other part is a thermometer. You guys are going to measure the temperature of the water. You're just going to fill a beaker with water, and then you're going to take a thermometer. Don't shake it down. You don't need to do that. Okay? Just take your thermometer and place it in that beaker, and then after 15-20 minutes you can read the temperature. So here's my thermometer, and on one side I see 10, I see 20, I see 30. And between each of these, and these are degrees Celsius, between each of these marks, I can see there's a halfway line here. And there's 1, 2, 3, 4, 1, 2, 4. There's 10 marks between the 10 and the 20. So the question is, what is delta for this particular thermometer? Is it 0.01 degrees, 0.1 degrees, 1 degrees, or what? What do you think? If this is 10 and this is 20, then that is 11, right? So each delta is 1 degree. It's a 1 degree increment. So when you use this thermometer, you should measure it out to the 10th of a centigrade, 100th of a centigrade, or what? It should be to the 10th. So what you want to do is make sure all your measurement is to the 10th, 1 decimal point over. Okay, so that's the thermometer that you guys are going to be using here. As far as your volumetric flask, I mean your graduated cylinder. Okay, this is the third items that you guys are going to be using. In terms of your graduated cylinder, we have 3 types of graduated cylinder. We have a 100 milliliter graduated cylinder. We have a 25 mil graduated cylinder. And we have a 10 mil graduated cylinder. If you look at the calibration in the graduated cylinder, I will see that there's 70 here. I could start anywhere, preferably not at the bottom, but somewhere in the middle. And then the next major line is up here at 80. It goes from 0 to 100 to the top. But the big lines, 70 to 80, and then if I look at the finer calibration, I can see that there are 5 marks here, and so if you take a look at this diagram, what is delta for the 100 milliliter graduated cylinder? If this is 70 and this is 80, then the distance between here and here is what? 1 milliliter, right? So when you read the graduated cylinder, the 100 milliliter graduated cylinder, you want to read it to the 10th of a place. Okay, you want to read it to the 10th of a place. Because if you have a meniscus that is like this, you want to get an eye level to that meniscus, so you have to bring this graduated cylinder right at eye level. Make sure that you're totally horizontal. Make sure that the lines in the front of the graduated cylinder match up with the lines in the back, because if it doesn't, then you're going to have some error. And then you want to read the bottom of the meniscus. You want to read the bottom of the meniscus, okay? And so this would be estimated as 70, 71, 72, 73, 74, between 74 and 75. Okay, so you know it's 74 point something. And that point is your error, is your uncertainty. That's your estimate. Now it looks like it might be halfway, so I would read this as 74, those are the certain values, 0.5. Because that's the estimate. I could have also read this as 74.4 or 74.7, but this is the error in the measurement. That's why I'm reading it to, that's why I have to look at my calibration, because it tells me how far I need to read this measuring device. Okay? So, again, that last number is an estimate of where you think that bottom of the meniscus lies between 74 and 75. And I say it lies in between. But you might have a different take on that. Okay. In terms of the 25 mil graduated cylinder, this is a bit tricky. Okay. For this particular cylinder, we have 15 here, and we have 13 here, all the way up to 25. 15 and 13. So over here, which doesn't have a number, we know it's 12. It's going to be in between that. Okay? And then there's 5 marks in between. Like that. So this is, sorry, I got that backwards. This is 13, this is 15. And this would be 14. Not 12. Okay? 13, 15, and then there's no 14 here. Does it by 2's? But you can think that 14 is here. So if this is 13, this line right here is 13, this next line would be 13.1? 13.2, exactly. So delta in this particular measurement is 0.1. Or, sorry, delta in this particular measurement is 0.2. Whenever you have a number that's not 1, but it's 0.2 or 0.5, then the error is still to the 100th, still to the 100th of a place, except this last number now can only be 5 or 0. It can only be 5 or 0. Now let me explain. Suppose I have a reading. Suppose I have a reading. This is the most difficult measuring device to use because it's not by tens, it's by 2's. But let's take an example. Suppose I have this. Okay? Suppose I have this. Now, if you take a look at this particular item, you can see that it's 13, 13.2, 13.4, 13.6. Okay? And it's either on the mark or halfway in between the mark. If it's on the mark, like this one, I would say 13.60. If it's anywhere in between, say it's like this, and the reason why you can see it better here is because it's blown up, but let's say it's in between the mark, then I would say 13.65. Okay? It's not 13.63, it's not 13.62, it's 13.65. When you have a 0.2 error here, then it's plus or minus 0.05. Plus or minus 0.05. It could be 0 or it could be 5. Okay? So remember, when you are reading the 25 mil graduated cylinder, your very last digit should be to the 100th of a place, and your very last digit should either be a 0 or a 5. Okay? This is one of those weird exceptions that we've been talking about in class. The last one is easy, because it's a 10 mil graduated cylinder. If I see here that this is 7, then this is 8, and I have 10 calibrations here. So each of these calibrations is 0.1 exactly. And so when I read a volume using this 10 mil graduated cylinder, I would read this to the what place? To the 100th of a place. Okay, so we're back to the only one that's difficult is the 25 mil graduated cylinder. Okay. The last measuring device that you guys are going to be using is the scale. And again, when you make sure you turn on the scale, and you're going to be like weighing a pencil, for example, make sure you tear it. Tearing simply means to zero the scale. So it reads 0, and then just place the pencil on there, and then you're just going to read the mass. And the numbers that are on the scale are all significant. So just write down everything that the scale provides. In this particular case, it'll measure it out to the thousandth of a gram, 0.001. Okay? So, this particular lab is straightforward in that all you have to do is take measurements. But the key to this lab, and what I will be looking for when I grade this lab, is how well you use the measuring device. That is, are you reading it properly with the correct precision? That's the key. Okay, you guys are going to be graded on that.